So under the whole operations section, you're going to now be able to multiply radical expressions. And if these look familiar, it's because you're basically doing what you did in the FOIL section. Rewrite number 1, and I'll erase this chunk up here. So the same rules apply, first, outer, inner, last, and then you could also have more complicated ones where you'd have to distribute larger numbers. Now I've made this stand out so that we can tell the numbers away from the radical versus the numbers under the radical. And so as we write this out, I see the first gives me 5 times 6, which is 30. And to show the steps and not make mistakes, I'll rewrite the square root of 5 times 10, which is 50. I won't bother writing 5 times 10 there. I think that's an okay step to skip, but I think it might be a little aggressive to try and move on past that. Then if I move to the outer, keeping in the order that it's normally done, I see positive times a negative, so I'm going to write minus 10, and then square root of 30. So I did my first, outer, so this is kind of a tracking problem, inner, and then I'll do my last. So if I do my inner, I got 4 times 6, so I'm going to write minus 24, and then 3 times 10 under the radical, square root of 30. And then moving on to my last, negative times a negative gives me a positive. 4 times 2 is 8, square root of 3 times 6, which is 18. And as you look at this, these types of problems really can become pretty wide, so organize your paper accordingly. Now in this, I look and I see, well, 2 of these can be combined, and then 2 of these are different, so maybe I simplify those. So I'll simplify these. I won't simplify these because I think it'll be easier to put them together and then save that for an extra step. So 30 square root of 50, I see that as 25 times 2, so I'll write 5 square root of 2. And notice that I'm not talking all through that anymore. And then minus 10 minus 24, I'll write minus 34 square root of 30. I would encourage that as a step. Plus 8, and when I see square root of 18, I'm thinking 9 times 2, so I'm going to write times 3 square root of 2. 30 times 5 becomes 150 square root of 2. Minus 34, I see this as 30 being 5 times 6, neither of which are perfect squares. 2 times 15, same comment, 10 times 3. So although it's such a large number, I don't think we can simplify that. So I'll write square root of 30 plus 24 square root of 2. The way this worked out, we ended up with 2 matches. So now we can put 150 and 24 together to get 174 square root 2 minus 34 square root of 30. And that'll be the answer, unless I made a mistake. Treat problem 2 as an on-your-own problem, and then compare it with what I have, and I'll put the whole answer up in about 5, 4, 3. Now, I'm almost finished with this problem, but I thought I'd pause midway through. And the reason I paused midway through is because these large numbers feel really strange. And it was only really coincidence when we did problem 1 that we ended up with 3 times 10 to be 30 and 5 times 6 to be 30. So that was accidental. It's not like it's a perfect square problem where things nicely match up. So here when we have these random radicals, they don't really combine nicely. So moving from this step, if you have anything different from what I have, double check to make sure you're happy with what you got. I got minus 30 square root of 42. And that's an even number. I really want to be able to simplify it more, but you can't. Plus 24 square root of 5. And I'm not talking too deeply about this because I know you've done this work. Minus 30 square root of 3. And like I said on the last one, unless I made a mistake, I think that's going to be totally simplified. So 24 square root of 70 minus 30 square root of 42 plus 24 square root of 5 minus 30 square root of 3. And, maybe a little strategy or a little tip I'll have. Like when you compare your work to an answer key or something like that, yeah, I think you kind of got this down now. But you're looking at what your teacher did, what the answer key did, to kind of figure out those steps and see where you were different. Or you could type in this whole problem to Wolfram Alpha, which really wouldn't take all that much time if you practiced it, and see what you get. You could also type it in your calculator and get that whole decimal approximation thing. So I put a star there and then an approximate symbol showing that you can figure out if that is correct. Now the reason I did that one more of an OYO problem is because I knew I'd be doing another one right here, beginning to end. So find the area of the rectangle in simplest form. And if I look at this, it's things with radicals. And clearly this is labeling that side. Clearly this is labeling the top. And since there's no units, we're just going to end up saying something by the end of this where we'll be like units squared, since this is an area problem. So the book and the people that made these types of problems, they were just thinking to themselves, how can we somehow make you guys use these concepts in a problem that's somewhat straightforward but not too intense? So there I have written 3 square root of 6 minus 10 and the radical times 4 square root of 5 minus 2 square root of 3. And that's what we do with area problems. We just know that, if this is 2 and that's 4, 2 times 4 gives us 8. So they're only making us multiply things with parentheses and radicals. Multiplying this out, I get 12 square root of 30. If you want, you can pause this and try it on your own, or you can tag along, but I don't want you to skip my explanation because I think it's always helpful to hear it a second time. Minus 6 square root of 18 for the outer, minus 4 square root of 50, plus 2 square root of 30. Now, let's say you ended up having something like the square root of 36. You could always simplify before you even began multiplying if you wanted. Okay, we got 12 square root of 30. I look and I see that I can combine that with this other square root of 30 over here. Again, that's a coincidence. So I will write 12 plus 2 is 14 square root of 30 minus 6 times 18 becomes 9 times 2, so I'll pull square root of 9 out and turn it into 3, minus 4 times 5 square roots of 2, because 25 and 2 gave me 50. And then if I pan this up, I'll write 14 square root of 30. And I think we saw in the earlier problem that we couldn't simplify that anymore, so I won't repeat that explanation. Minus 18 square root of 2, minus 20 square root of 2. And then I can only rewrite the square root of 30. And then I'm going to subtract 18 and 20 to get minus 38 square root of 2. I'm going to box this, but then maybe off to the side I'll write units squared. I think your teachers will be a little bit more flexible when you get into problems like this because it's not very real applying this somewhere. It's very, very much about the radicals and less about the area and perimeter problems. It's like they slapped this onto the end of this section. And I think you probably noticed that because you've done multiple types of problems, and then at the very end, here is this problem with a rectangle thrown into the mix. Okay, this is a crazy ton of practice, and I think it's a crazy ton of good practice because all along the way you're continuing to simplify radicals, making it more automatic before getting into the end of the section.